important nutrient as essential element for all living organisms by the synthesis of amino acid, protein, enzyme. This nitrogen, from this nitrogen, whatever the amino acid are there, the amino acid synthesized, then whatever the protein are there, the protein contains this nitrogen part. Whatever the enzymes are there, that enzyme also contains nitrogen is there. And here you can see important part of atmospheric air content and infrared one in atmosphere. Nitrogen concentration is about 78%. And here what will happen if there is no nitrogen? Is anyone can give the answer of this question? If nitrogen is not there, what will be the result of absence of nitrogen? Question number 76. What will be the result of what will happen if there is no nitrogen is there in atmosphere? Fifty-two, 78, 80, 84.
Sir,
What will happen if nitrogen is not there?
sir, I didn't understand it, sir.
What happens if there is no nitrogen?
Sir, your voice is not clear, sir.
If nitrogen is not there in atmosphere, what will happen? If nitrogen is not there, what will be the result? What happens if there is no nitrogen in atmosphere?
Global warm decreases.
Okay, yes.
Sir, density of air decreases.
Density of air decreases. Then I'm expecting answer in terms of our food, in terms of agriculture, in terms of plant. So whatever the root system is there of plant and plant growth will be stunted, will be stopped, will be decreases. Or you can say whatever the older leaves which turns into yellow color if this nitrogen is not there. There is final result in there is decrease in crop production or it would be dangerous for microorganisms or soil microorganisms. Okay, if this nitrogen is not there, this all will be the result of that one. That is one food system and plant growth will be stunted.
Hello, Ka.
Then older leaves turn into yellow, then decrease in crop production and soil microorganism life becomes dangerous. This is all due to the absence of nitrogen in atmosphere. Okay, and we will need to discuss this nitrogen cycle. Nitrogen cycle. What is nitrogen cycle? This is the circulation of or cyclic movement of nitrogen from atmosphere soil. Okay, whatever the atmospheric nitrogen is there, we cannot consume that atmospheric nitrogen as such. Or even the plant also, they cannot take this nitrogen, atmospheric nitrogen as such. So there is one mechanism, that is, you can say nitrogen cycle, and that nitrogen cycle is the circulation or cyclic movement of nitrogen from atmosphere, that is physical or abiotic component, to the soil, that is biotic component, and that is come back into the atmosphere again. So this whole cycle is known as nitrogen cycle. Okay, this whole cycle is known as nitrogen cycle. So here, now you can see this slide, the different steps are involved in nitrogen cycle. One, that is nitrogen fixation. What is nitrogen fixation? Already know, you have already studied, and already I mentioned that plant cannot utilize or animal cannot utilize this atmospheric nitrogen. So this nitrogen, atmospheric nitrogen, should be converted into a utilizable form. The usable form, that is ammonia. Ammonia is the utilizable form of nitrogen. So in this first step, this is first step involved in nitrogen cycle, that is nitrogen fixation. And this nitrogen fixation is the first step in nitrogen cycle. And here, the whatever the atmospheric nitrogen is there, that is conversion of this atmospheric nitrogen into the ammonia by living organism is known as nitrogen fixation. We have already studied this nitrogen fixation case studies examples. That is, the process is carried out by some leguminous plant, such as groundnut, such as even small bacteria. They can fix the atmospheric ammonia, atmospheric nitrogen to the ammonia. That is root noodles. Then, for example, of this bacteria, Azotobacter, Clostridium, then Rhizodium, Nostoc, and Anabella. Those microorganisms fix the atmospheric nitrogen. Then, second step, that is nitrogen assimilation. Whatever the nitrogen in first step, which is second step is the nitrogen assimilation. This step absorbing whatever the nitrate and ammonia, which is mixed in first step, into the organic nitrogen. Organic nitrogen, and that organic nitrogen, this process mixing of nitrate and ammonia into the organic nitrogen, this process is known as nitrogen assimilation. And this organic nitrogen transferred into animal body when plants are eaten by the animal. When plants are eaten by the animal, this organic nitrogen transferred into the body of animal or transferred into the human. Okay. Then third step, that is ammonification. Okay. Ammonification is the third step. Here, this ammonification means the process of converting organic nitrogen into again ammonia after when animal becomes die. This process is known as ammonification, and it's also known as mineralization. And this in this one, NH2 is converted into NH3, and this process is carried out by some saprophytes like fungi, like bacteria, and the ammonia is also produced from some you can say volcanic eruption and some of the secretory products of animals. Okay, this is the third step. And then we come to next step, that is nitrification. In nitrification, what will happen? Bacteria which is involved in nitrification is known as nitrifying bacteria. And in this one, whatever the ammonia is there, when we will get the ammonia from ammonification, and that ammonia converted into the nitrite, and whatever the microorganism involved in this one, by converting ammonia into the nitrite, that microorganisms known as nitrifying bacteria. For example, Nitromonas and Nitrococcus are the nitrifying bacteria. Okay. Then, in one, nitrites are converted into the nitrate first. Okay. With the help of nitrobacter. And last step, that is denitrification step. And denitrification means nitrites are converted into molecular nitrogen. Nitrous oxide is known as this denitrification. In order to maintain the equilibrium of nitrogen in atmosphere. So this is the complete nitrogen cycle. And bacteria what is the denitrification is known as, or they are known as nitrifying bacteria. And for example, that is Thiobacillus nitrificans, Pseudomonas nitrificans, and Micrococcus nitrificans are the bacteria responsible for denitrification process. Okay. So here guys, you will get clear idea about this nitrogen cycle. Whatever this is a atmospheric nitrogen, and you cannot take this atmospheric nitrogen as such. So in first step, this atmospheric nitrogen convert into ammonia, and this ammonia convert into nitrite with the help of nitrifying bacteria. And whatever the ammonia and nitrite, this is taken by these plants or this plant, then this is converted into organic nitrogen. Okay, this is organic nitrogen, that is ammonia or nitrite. And this nitrite through the plant, it gets eaten by plant, get protein for the animal body, and this nitrogen is transferred to the animal body. Okay, then what will happen? This animal, when this animal get died, in that one, the organic nitrogen from this animal or from this plant waste or animal etc. That is nitrogenous waste. This animal plant waste and animal etc. The nitrogenous waste, and animal body contains protein. So whatever that protein, that is organic nitrogen, and that organic nitrogen converted into the ammonia when animal becomes died. Okay, and this process is done by we can say fungi and bacteria, and again this organic nitrogen converted to ammonia, and this ammonia converted to this nitrite by using this nitrifying bacteria, and then again this nitrite gets utilized for this we can say plant, or some of the nitrogen free ammonia or free nitrogen is released into the atmospheric nitrogen by denitrification process. Okay. Then some of the problem associated with the nitrogen, we will discuss that one also. This is a complete whole structure of nitrogen cycle. How we will get the protein from this nitrogen, that is through this nitrogen cycle. Okay. Then another terminology, but before discussing before that one, we will discuss some three terminology, that is problem associated with if the nitrogen level is increasing the atmosphere, or what will happen. So at that time there is acid rain formation. All the people who are reading this one, acid rain formation is the starting period of rainy season. Whatever the nitrogen is there in the atmosphere, that nitrogen is increased with the form of acid rain. There is acid rain formation. It is also due to the increased amount of nitrogen. Then second one, acidification of oil and lake. Many soil and lake are acidified due to increased nitrogen content in the atmosphere. Then due to increased content of this nitrogen, there is increase in death of plant is also there. So this is about nitrogen cycle and increased level of nitrogen to the atmosphere. acid pool. This is nitrogen cycle, and after that we will discuss this amino acid pool. So amino acid pool is whatever the reserve stock of amino acid into the plasma and into the tissue. That is, you can say that is the amino acid pool. And approximately 100 gram of amino acids remain in dynamic state, remain present in the plasma and blood, and that is known as reserve stock or amino acid pool. This is constantly replenished as they are utilized. This gold one is utilized and because with the so it's whatever the amount is there in amino acid pool, that is constant one. So here you will get a clear idea. So as we know, this whatever the amino protein is there, protein is converted into amino acid. Then that amino acid utilized for different purposes through the process of transamination is converted to glutamate. Amino acid converted to glutamate. That means this amino acid used for synthesis of new protein material. Then this amino acid used for synthesis of non-protein nitrogenous substances, that is porphyrins, creatines, purines, pyrimidines, then thyroid, some hormones. So here, whatever the amino acid we are taking through the digestion, that is we are taking through the digestion, that is 70 to 100 gram protein daily we are taking from the digestion. Then we will get the protein from synthesis of non-essential amino acid. Then degradation of old protein material. These three are the sources of amino acid. We will get the amino acid through these three sources. That is one, digestion of dietary protein. From that protein, we will get amino acid. The synthesis of non-essential amino acid, we will get this amino acid. And then third one, that is degradation of old body protein. We will get 300 to 400 per day. Okay. Then here we will get amino acid. Get the amino acid through these three ways, and this amino acid utilized for synthesis of new protein, that is 300 to 400 gram per day. Then synthesis of new acid, then catalyzed for catabolized in liver, that is 13 to 35 gram per day for the energy purpose. Then for the ketogenic fat synthesis, and then glycogenic, that is glucose synthesis. So those are the in and out mechanism of amino acid, and here this where the 100 gram of amino acid are stored, that is as an amino acid pool. Okay, so this is about amino acid pool. Exactly what is amino acid pool here, and what is the importance of amino acid? So it allows high turnover of amino acid. Then amino acid are made available and efficiently does not occur immediately. Okay, whatever the amino acids are there, this amino acid pool made the amino acids are available in case of deficiency, and this is constantly replenished by dietary fiber. This means new amino acids comes and old amino acids are utilized for another reason, or we can say energy purpose, we can say new acid synthesis. So constantly replenished by the dietary protein. And this urea secretion is the index of nitrogen loss from the body. Whatever the urea is going on, that is the idea about nitrogen loss, and it should be replenished by dietary protein to maintain the nitrogen balance in the body. Okay, this is about importance of amino acid food in our body. Then, what is protein turnover? This is very important term. In this health, the health there is constant degradation of gold. Protein turnover means health there is constant degradation of gold and used protein, which is replaced by synthesis of new protein. So this is the protein turnover. Okay, in amino acid there is constant degradation of old and used protein material and which is replaced by synthesis of new protein material, and this is known as protein turnover. In normal healthy individual, about 300 to 400 gram of protein turnover is every day. That means 300 to 400 old protein is can be degraded and utilized daily, and we will get 300 to 400 new protein is from balance of that in and out. Okay, this is about protein turnover. So we have discussed this. We can say nitrogen cycle. Then after we have discussed amino acid pool, and then next one very important terminology, very important thing, that is nitrogen balance. Here I need to do brief description about this nitrogen balance. So nitrogen balance is the comparison between intake and nitrogen loss from the body. That is nitrogen balance. It is index of growth, or we can say anaerobic status of our body. Whatever the proteins are there and stored source of nitrogen in the body, that is 10 to 15% of energy derived from the protein. Whatever we have discussed that one, whatever the carbon later in amino acid, that is utilized for the energy purpose, and it provides 10 to 15% of the energy which is derived from the protein. Okay, but in absence of carbohydrate, amino acids are used for providing energy to the we can say it provides the energy. As a result of nitrogen is excreted to the body, that is lost in the form of urea and nitrogenous non-nitrogenous product also. This is the important thing. Then we can say what is nitrogen equilibrium. The second one, nitrogen equilibrium. So what is this? So nitrogen equilibrium is whatever the nitrogen intake is equal to daily loss to the increase is X. So we can say in simple words, that is intake is equal to loss. Intake is equal to loss. Intake of nitrogen is equal to loss of nitrogen at that position. That is nitrogen equilibrium. Then next one, next important terminology, that is positive nitrogen balance. What is this positive nitrogen balance? When intake is greater than loss, when intake of food, intake of nitrogen is greater than loss, that time we can choose positive nitrogen balance is there. So when this positive nitrogen balance, when this situation will arise, yes, in case of growth, pregnancy, recovery from illness, this leads to the positive nitrogen balance. In that one, we will take the more amount of protein, we will take the more amount of nitrogen, and we will release the less amount of nitrogen. Our body will release less amount of nitrogen, less amount of urea. There is that means loss is less than intake. So hormones lead to the positive nitrogen balance. Growth hormones, insulin, adrenal. This leads to the positive nitrogen balance in the body. Then second thing, that is negative nitrogen in the body, nitrogen balance. So nitrogen balance, negative nitrogen balance means somewhat opposite to the positive nitrogen balance. That is intake is less than output. That is negative nitrogen balance. Here, guys, you can see in this negative nitrogen balance, we can see case of chronic acute illness, protein deficiency, then we go for starvation, and hormone also lead to the negative balance. somewhat cardiosteroids, B4, those are also used to be nitrogen balance. So guys, this is about the nitrogen balance in the body. That is equilibrium nitrogen balance, positive nitrogen balance, negative nitrogen balance. And one important thing I need to say when we are discussing about the money factor, at that time we should say like maintain the money account, maintain the money account and remain wealthy. Maintain the money account and remain wealthy. Here we will say maintain the nitrogen or maintain the protein account and remain healthy. This is the first sentence in there is very important related to the nitrogen balance and related to the protein balance. Okay, guys, if you have any doubt in this one, question number 78, 105, yes, yes, 105, you have doubt
No, sir.
here. So, this portion of our, we can say, nitrogen balance and nitrogen cycle, here we have finished that one, nitrogen balance and nitrogen food. And from tomorrow's class, we will start the evaluation of protein quality. And then I will take the attendance. Date, 9, we will have. Okay, no problem. Okay, guys, thank you for attending the class. You can leave the meeting. Our class is completed here. You can leave the meeting.